Hello everybody, Scoop It Up here, and today I'm going to be doing a video showing how you can create your own programs for BlueStone. Now BlueStone, if you haven't already known or seen, is the redstone computer that I created in Minecraft. So if you guys are interested, continue watching, and I am going to be showing you guys what all of these different parts do, all the different colors, how they interact with the computer, and how you, as a user, can create your own programs. So yeah, pretty cool. So let's get started with how you actually input the machine code for the program. As you can see, there are these lines of program memory. This is line 1 through 15, 16 through 31, 32 through 47, and 48 through 63. The first one is actually missing one. This is address 0 because there is no address 0. It's just 1 through 63. To make it easier to program, so that you're not cramped in here inputting your code, I decided to lay it out in a flat line where you can input your number and then copy and paste using single player commands these parts into your program memory. So to input a value, you use a redstone torch and you actually place them on the different parts of the line. Now it kind of skips two, so this is outputting to a line. This does not. This does not. Does not. That's to prevent signal interference, obviously. So yeah, when you input a value, you need to make sure that you have them in the right location, so they're actually outputting to the redstone below. And basically, if I were to input this value, every time there's a torch, it's a 1. Every time there isn't a torch, it's a 0. And the way the computer reads this is this line gets unpowered, these torches turn on, and output the power to the rest of the computer. Yeah. So that's how you program, like physically program the computer. And now I'm going to get into what each kind of part of this program memory does. So, starting with the saving and loading of memory, probably the most important part of any computer. This white part will tell the computer whether to read from RAM and save to a register or a location, or read from the register and save to RAM. So this is if the value is 0, this is if the value is 1. And basically, just to explain this, if you haven't already figured it out, the way that this computer works is it actually there's two different ways it can work with the memory. It can either load a location, so let's say read the user input and save that to the RAM, or it can save a value to RAM and load a value from RAM and save it to a location, such as the ALU. And each of those can be done in one clock tick. So in one clock it can load from a location, save to RAM, or load from RAM and save to a location. And so that's what this yellow and green part is for. It's all for memory. And so now I'm going to explain how it actually works. So let's say this is a value of 0, which means we're going to read RAM and save to register. So that means that this bottom part here is what we're going to be looking at. If this was on, we'd be reading from register and saving to RAM, so we'd be looking at this top part. This is just how I kind of organize the system. It's the same throughout for all these signs, just so you guys can kind of see it with a little bit more organization. So, first thing, if we are reading from RAM and saving to location, a register, we're going to read the RAM here and here, these two green parts, and it's a 4-bit address from 1 to 15. The address 0 or 0000 isn't used. There's only 15 addresses. And if we input a value here, we're going to be loading to bus A. And if we input a value here, we're going to be loading to bus B. Now the reason why there's two different reads is because we're actually using dual read RAM, which means I can read two addresses at the same time and output them to my ALU. So if I wanted to add two numbers, for instance, I could load the two numbers I want to add and save to the ALU all in one clock tick, which makes the computer a lot faster than what it normally would be. And it actually is important, the fact that this loads to bus A and this to bus B, because of where we want to save these locations to. So for the ALU, our A value is going to be sent to ALU A, and our B value is going to be sent to ALU B. To save to the ALU, we're going to send or input a value of 0001 to this address here. So load from RAM and save to ALU. Or we can save to 0010, which will save to the outputs of the computer. So the A value will get sent to a binary display, which I have, and the B value will get sent to the serial out. Now, if you don't know what either of these are, basically, in the user input part of the computer, which is here, these 8 lamps are actually a binary display. Most significant bit here, least significant bit here, and that's how this computer always is. The least significant bit is always on the right side, because that's where it should be. I don't know why some people do it in the reverse order, but whatever. So you can output here, and the A value that you're loading will get sent here, and the B value will get sent to the serial out. So the computer is equipped with a serial out system. I'm not going to be explaining it in this video. In the next video I will be. But basically I can output binary values through only one wire to external devices, like displays or math processors or RAM or whatever you want. In the next video I'll be explaining how you can actually use these in your programs to create some pretty cool things. So yeah, that's the where is it here? So saving to an output, and then the next four, which happens to be the last four, are your GPU functions, or graphics processing unit functions. And so they take the form AB. You're inputting XY coordinates, and your X value is going to be your A, and your B value is going to be your B. And you can save these to these 4 different locations, and I'll explain what these are in a little bit. But just remember these for now. So point 1 save, point 2 save, point 1 clear, and point 2 clear. And when I get to the graphics functions, I'll explain why there's actually 2 points and why there's a save and a clear. Yeah, so that's read RAM and save to register. Now if we want to read from a register and save to RAM, say we want to load user input 1, save to RAM, over here the green part is what register location we would load. So all of the different addresses are here from where we want to load from. ALU 0000, user input 1 and 2 are binary values 1 and 2. Random number generator is binary 3. Bit count is a little bit different. It's something I designed to make division a little faster. But basically, if you have a 3-bit binary value, let's say this is 111, which is 7, but this computer is capable of 8 bits. What the bit count is, it'll actually return a value of the difference between the most significant bit is the least significant, and the least significant bit. So if we had a 5-bit number like this, 10111, it would return a value of 5, because the difference between the highest bit that's on and the lowest bit that's on, or actually not the lowest bit that's on, the lowest bit in general, because you could have a value of 100 and it would still output 3. Basically just how large the number is in bits. If you don't know what I'm talking about, you probably won't need to use it. Then we have our 2 serial inputs and our 8 lines of ROM. So values 7 through 14 are the 8 lines of ROM, and those can be found just around here. I labeled them and color-coded them just for your convenience, and you input values here just as you would for the program. So using torches, this for instance would be a value of 7, always least significant bit on the right side. And those get sent to the main bus and to RAM. And then so that's loading from register, and then you select which 4-bit RAM address you want to save to using this. And again, this is if this is 1, and this is if this is 0. Yeah. So moving on, this purple part is the executing function. So 0 is, if this bit is 0, it means we're doing an ALU function. If this bit is on, we're doing a GPU function, or graphics processing unit, and arithmetic logic unit. So I'm going to talk about the ALU first. ALU is on the bottom here. I'll go through all the different functions that it's capable of. We have disable A, disable B. These basically turn A or B to 0. Invert A, invert B, increment by 1. This is also known as carry in. Disable carry. This will cause the ALU or the adder to act as an XOR gate. Then we have disable adder, and this will cause the two inputs to OR together. Invert C, or invert the output. And then we have two left shifts, and this allows us to set the least significant bit to 1 or to 0. And this is useful for division programs, square root programs, stuff like that. It just makes it a lot easier and a lot faster to do stuff like this. Otherwise, you have to like shift and then increment by 1, and it's just a hassle. So yeah. And then, of course, we have a right shift as well. Only one of these, not two. Yeah, that's the ALU, and you can create any combination of these to create whatever function you want. For instance, if you wanted to do A and B, I would invert A, invert B, disable adder so they OR together, and then invert C. So it's basically like logic that you're used to, just inputting in machine code. And then our GPU functions are on the top here. The GPU functions are actually split apart into 3-bit sections. So these first 3 bits are separate from these last 3 bits. The GPU that I have here, or this screen, is actually capable of drawing and clearing selections or pixels at the same time. So for instance, if I had this pixel and I wanted to move it, rather than clearing the entire screen and then drawing this point beside it, I could actually clear this individual point and then draw this individual point at the same time. So it would look as if this pixel just moved, which is a lot more professional in my opinion, and a lot nicer to look at for games and stuff like that. And that's actually why this screen is so big and not a small screen like the, I guess you could say, new technologies of Minecraft, if there is such a thing. And so the other thing is the GPU actually has 4 different functions. So there's dot mode, and this is where I ask you to remember the fact that you can input 2 points. So let's say these are 2 points that I've drawn, and let's say these points are inputted in the graphics card. If I wanted to do dot mode, which is where you draw just an individual pixel, if this is point 1 and this is point 2, point 2 will actually be negated, and it will only output point 1. And that's useful if you want to draw just an individual pixel. But what you can also do is you can, in between point 1 and 2, you can actually fill all of the x values between these 2 points, or all of the y values between these 2 points. So for instance, if I wanted to input all of the x values between, I would end up with a horizontal line here and a horizontal line here. And that's because I'm filling all of the x values between these two, and I have 2 y values, therefore I'm going to have these horizontal lines. And the same would happen if I were to fill all the y values, so I would get 2 vertical lines between these 2 pixels. Or if I did both, then I would get a full square selection with these 2 points as kind of the extents or the diagonals of the square. And that's useful for creating selections. And you can actually clear and save selections at the same time, which is quite remarkable. You can do it all at the same time, which is very, very useful. If, say, you wanted to draw a square that's hollow and the inside isn't drawn, just as a final note, you would first fill your x values to get to horizontal lines, and then in the next clock cycle you would fill your vertical lines, and that would create a nice square. So yeah, that's the GPU functions. And so here I wrote down what the codes are. These first 2 bits here are where you input the binary value for the function select, and then this is you input this if you want to draw, and then this is where you input your clear function select, and you input this if you want to clear a function, or sorry, clear a selection. So yeah, that's the ALU and the GPU. Moving on, this is the goto or conditional goto logic system of the computer, the red, pink, and orange part. If you don't know what conditional goto is, I highly recommend that you watch my video, How Redstone Computers Work. There's a really good outline on how conditional goto actually works. But if you do know, then you should have no problems. So the red part is a 4-bit goto address of what line of code the computer should go to next if the condition is false. And the pink is the exact same, a 6-bit goto address, but this is for if the condition is true. Now, by default, for an address condition of 0000, your value is always going to be false. So if you're not looking for a condition, then you don't need to input anything here, and you only need to input where you want to go to next. The orange is the condition that you want to look for your goto. So it's a 4-bit condition. There are 15 different conditions, and these will affect your goto system. So I kind of gave all the codes for the different conditions, and I'll go through them quickly. So 0000, as said before, is not used. NA, not applicable. Values 1 to 4 are your 4 Boolean logic flags. And I explained this in a previous video, but basically you can save these true or false values for later use in programs. They're very useful, and I'll talk about over here is where you actually save these values, so I'll talk about them a little bit more later. Then you have your user input logic. So the user input has 2 possible ways you can interact with the computer. One of them, or actually 3. One is data, but you can also use these conditions, these logic switches. They're just T flip-flops to turn it on and off these logic switches. And you can also select what you want your feed to be. So if this is on, you're selecting your buttons. If this is off, then you're feeding from your directional pad, and your up is logic 1, down is 2, left is 3, and right is 4. And I'm just going to turn this on so I don't forget. And I just leave this here so you know. 1 to 4 are your logic 1 through 4. Then you have your shift underflow and your shift overflow. If you don't know what these are, then you probably don't need to use them. And then you have your comparator outputs. So basically, every time you load a number into the ALU, it'll also compare the 2 numbers, and it'll give you an output if A is equal to B, A is greater than B, or A is less than B. One of these 3 will always be on, and you can access these using the address. And then we have is the random number generator on? If it's on, it'll give a true. If it's off, it'll give a false. And this is useful if you need to stop the program, for instance, if the random number generator is off. And then finally, we have random branching, so it'll randomly select where you want to go. So yeah, that's the goto or conditional goto logic. Finally, we have these last 2 parts. These are actually probably the most convoluted parts, so I'm going to go a little bit slower with these. Basically, for both of them, there is a selector. If it's 0, then we're going to be using a serial function, and if it's on, we're going to be using a different one. So if these are both off, we're going to be looking at the top here, and they're for serial. And again, I'll talk about the serial more later, but just to kind of explain it quickly. Here you input a 4-bit function for the serial. So the format of a serial output is 4 bits function and then 8 bits data. So this is the 4 bits function that you want to have the external device execute. You don't have to use it. All external devices don't have to use it, but if you need it, this is where it is. And then over here is a binary value from 1 to 15 of which port you want to output your external serial output to. 0000 does not output to anything, and yeah, it just doesn't output. So there's 15 ports, 1 through 15. Yeah. Now, if this value, if this bit here is on, then you're going to be assigning true or false values to your flags or your Boolean logic switches. So the first bit here will select whether you want to set the switch to true or to false. So if this is 0, then you're going to be setting it to true. If this is 1, you're going to be setting it to false. And these 3 bits here are which flag you wanna switch. So values 1 through 4 are flags 1 through 4. And again, these will output to the address or the condition for the conditional goto. And basically, this exact same thing, that the way that the flags work, with this setting them to true or false, and these 3 being the selectors, is how the indicators work. So the computer has 4 indicators, so that the user can look at them. They are, if you haven't seen my previous videos over here, indicators 1 through 4. And so I use these to tell the user that the computer has acknowledged an input and is waiting for another input, for instance. That's how you can use them in a program. And so again, this one will set the value to on or off, and then these 3 will change the 1 through 4 indicators. And the only difference is that there is also a 5th function, 101, which will clear all of the indicators. And that's the only difference between the flags and the indicators. So yeah, that is how you program BlueStone. If you guys have any questions, feel free to leave them in the comments below. I will try my best to answer them as best as possible. I don't know, but I may need to make another video clarifying some things. I don't know how easy this was to follow, but hopefully you guys kind of got the general gist. I recommend that you do download this world file. It's in the description. It will definitely help you out to fly around and kind of look at everything, how it all works, read the signs again, maybe rewatch this video, and hopefully by the end of it, you guys will be writing your own programs. If you do manage to create some pretty cool programs, feel free to send them to me, maybe even make a video, and I will be sure to acknowledge them in later videos and leave links to them for all people to see. So yeah, that's that. Hope this helped. And again, if you have any questions, leave them in the comments. Thanks for watching, guys, and I will see you next time.